Hi everybody. Before we get started, let's go ahead and state the obvious. Our sum here is certainly positive sum because it's a sum of what I think about 90 odd numbers. Okay, so it's greater than 0. Now, as far as the indexing go, it's useful to think of 179 as 2 times 90 because there's a nice induction proof for what this sum actually is. Okay, so this 179 is 2 times 90 minus 1. All right. And we're looking for the number, the minimum number of plus signs changed to minus signs so that S will become negative right here, become negative. Okay, let's move along. There's a result, I won't prove it. It's a kind of a standard classic induction proof. It's a pretty easy induction proof. One simple example would be for K equals 3. Sort of a sanity check, even though this thing's fairly believable. And it has a neat geometric interpretation, as I recall. That gives us 1 plus 3 plus 5 is equal to 3 squared. Okay, and we're going to use this fact 2 or maybe 3 times. Okay, now the idea on this, folks, is to we need a positive range. We need the first group of positive numbers to be less than the negative range. Okay, so let me just go through the process here for that to make sense. I'm sure it makes sense already to most of you, but half of our sum here, okay, notice that our sum would be 8100 by our little rule up there, and half of 8100 is 4050. Now notice this piece right here is very, very useful because 4050 is between 63 squared, and y'all, I think I made a mistake on that. That should be 64 squared. Yeah, 64 squared. That statement's true, but we need 64. Okay, so that's 64 squared, and that gives us a way to process this list here. Notice that 2 times 63 minus 1 is equal to, is that 125? Yep. All right. And then 2 times 64 plus 1 is, of course, minus 1, excuse me, is, of course, 127. Is 127. Okay. Now that helps us to create start and end conditions for this list up here that we're trying to create. A positive range. The beginning positive range should be less than the ending negative range. And here's the list. I just wrote it up in advance so we wouldn't have to waste time for my slow writing here. But the 125 you see right here is the 125 you see right here. And then you got 179 right here. Now, so it's clear that there are 63 values here, right? 63 integers. 63 values here, and there's 27 values here, which is going to correspond 63 and 27 sum up to the 90, okay? And so the answer to the question would be 27 because the way the question is worded, let me get that circle. Sign changes, if you want to call it that. Let's just call it that. And it's the last 27. And y'all, this is fairly neat. It's a lot simpler than you might think. I had to view Wei Tan's solution at the SMO website or the COCO website. But one way to check this is change this to 127 and change this to 129, and you'll see that this would be positive. This is as sharp as it gets right here. Okay, again, you could change this to 127, include one more positive number right here, and then knock this up to minus 129. Okay, and you would see that this whole thing would be positive. All right, so this gets the job done, and there are 27. There's 63 numbers in this list without having to worry about the indexing, and 27 numbers in this list right here. So the answer to the question is, what is the minimum number of sign changes? Okay, let me put 27 right here as the answer to the question. And again, I looked at the problem for around 30 minutes and didn't know. It didn't occur. It's easy once you see. It's like so many things in math. Once you see the solution, you got the answer. But it's a simple idea. But I was wondering about how to do it at a rear. It was a mess the way I was thinking about it. But all of this stuff is incontrovertibly true about the beginning positive range and the ending negative range, and that's just simply because it's an increasing sequence, right? Increasing sequence. If it wasn't increasing, if it was something different, then you couldn't make this simple assumption that you have a beginning positive range, like we found right here, okay, and a ending negative range, okay? So anyway, that does it, and hope you enjoyed it.